Okay, hi everyone. We're going to be doing Chapter 7, Section 7 here. We're going to be taking a look at factoring special products. And before we begin, I just really want to emphasize that this is really just factoring anything we've been factoring already. So I don't want to say this is an optional lesson, but if you can get the hang and see the patterns that are forming, you're definitely going to get a lot more out of this than if you were just, I don't know, going through these blindly like we always have. So let's get started with these. We're going to take a look at our, yeah, there we go. We're factoring special products here. What do we see? We've got, maybe make this a little bit bigger for you. Or not, I don't know. Come on. There we go. Oh, too much, too much, too much. All right, this is a little better. All right, so we got the working with a partner. We got some algebra tiles here, and we're going to write down first of all what we see. Again, over here, we're seeing that that's an x, that's an x, that's a -1. This is an x, this is an x, that's a +1. And so that one's pretty easy to see. That's x squared plus 1 and x squared minus 1. But I want you to take a look at what happens here with these tiles. This tile, let me highlight them. This tile here in yellow and this tile over here in yellow, that makes a 0 pair. And then also, if we take a look, let's get a different yellow. Let's use green. This green negative tile over here and this green positive tile here, they make a 0 pair as well. So really, when you FOIL it out, you get this 4x squared, 1, 2, 3, 4x squares. These guys are 0 pairs, so they get canceled out. And you just get the -1 here. So that's why when we have it, we got 4x squared minus 1. Taking a look at this one, looks a heck of a lot the same as the other one. This is x. This side is also a length of x. There's a -1. This is also an x, and a -1. But you notice over here, when you do -1 times -1, you get a +1 over here. So that is 2x minus 1, 2x minus 1. And we get the pattern over here, 4x squared minus 4x plus 1. I don't know if you can see how that pattern is going to happen, but maybe that's a 4x squared for sure. That's a minus 2x. That's a minus 2x. And then a plus 1. I feel kind of bad about having done it that way for reasons. This one is also very similar to what we had before. We've got this side is 2x plus 1. This side's also 2x plus 1, so we're just going to square that. Okay, so take a look at how beautifully symmetric this is. You have each row is the same, and this bottom row here is the same as this vertical row here. Everything is beautifully laid out and symmetric. This one, not so much. This is an x and a -1. X minus 2. So this does not have that beautiful symmetry that we saw in the previous one. 2x minus 2. So that one's different. It's just different. Okay? So use tiles to complete the rectangular arrays in each of the 3 different factored forms that were special. Well, one form that we saw, if this was a 3x, this is also a 3x, is if we had +2 and +2 over here. So that would make these all positive, since we're multiplying a positive times a positive. This is also positive x times 1, so that's, I don't know why I put a plus, I should put, these are positives, and then these are also positives over here. So if you see that, 3x plus 2 squared. Well, the first term and last term are pretty easy. That's just 3x times 3x is 9x squared. I'm going to leave a big blank over here. 2 times 2 is plus 4. And in the middle here, what we're going to get is, well, we can just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But you can see it here too. 2 times 3 is 6. And you're going to get the 6 on the vertical side and the 6 in the bottom. So that's actually going to give us 12x. Okay? Over here, the other option was maybe we did 3x minus 2 and then another 3x minus 2. So in that case, all of these are now minuses. But when we get to the bottom over here, that's going to be a minus 2 times a minus 2, so that's plus 4. So this pattern here would be 3x minus 2 squared. And so what would be the pattern if we have a square of a difference? Again, the first and last terms are pretty easy, 9x squared, and then instead of a plus 4, we get a minus 4, because we're doing minus 2 times minus 2. And in the center area here, it's actually the same rules. We got a 3x times a negative 2, that's a negative 6x, and we're just going to double that because of the square. So negative 6x plus negative 6x is negative 12x. So that's the pattern for the square of a difference. And this is the square of a sum. And then this one is like a hybrid between the two of them. This is a 3x. We'll make this a minus 2. We'll make this a 3x and then the plus 2. Over here, these are all going to be minus. Over here, these are all going to be plus. And then these are all going to be minus because we have a minus 2 times a positive 1. So when you work on this one, you're going to get a 3x minus 2 and then a 3x plus 2. And that's going to yield, well, you still get the 9x squared. You still get the minus 4 because you have a plus 2 times a minus 2. You get a minus 4 here, which means I made a mistake somewhere else. But in the middle here, these guys all form 0 pairs. I'm going to highlight them for you. This is all positive. These are all negative. We got 6 positive tiles and 6 negative tiles, so they form a 0 pair, and which means that, I could write a plus 0x if I, really chose to, and I'm trying to find my cursor right there. It is. I could put a plus 0x, but who really wants to put a 0x? So this is a sum and difference. It was, when I was in high school, that was my favorite one, the sum and difference. I guess if you're kind of a math nerd, you get favorite factors. I don't know, favorite factor tiles. I don't know the way that works. And the mistake that I made earlier is this one right over here. This should be a plus 4. I even put positive tiles here, and you guys still let me write a minus 4. Thanks a lot. Okay, let's move on here. Let's try and figure this out. Let's see, 25x squared plus 1. Those are both perfect squares. Perfect square. This one right here, perfect square. Which means the square root of 25x squared is just 5x. And then the square of plus square root of 1 is also 1. And then, yeah, that's just this plus right here. That just means that this one right here is going to be a plus. So that is gorgeous. 5x plus 1 squared. You also notice that the pattern continues here. You got 5x times 1 is 5x, and when you double it, you get that 10x. How about this one? Again, perfect square, so that's a 5x, and the square root of plus 1 is also a 1. but this time you got a minus. So that's going to be minus 1. So that's perfect squares. How about this one? This one, it looks visually different than the other two because there is no linear term. There's no bx. So no bx. So you got 5x plus 1 and a 5x minus 1. That's the sum and difference. My favorite. Okay. Sounds good? I think it sounds good. Let's move on. Okay, polynomial, trinomial, we already know those. I'm going to skip those. Here are those two patterns that we talked about. More perfect square trinomials, and then now we're going to try them. Okay, so let's see. S squared, perfect square, that's S times S. 49, that's a perfect square, that's 7 times 7. So when I do this one, I just got to figure out, is this a sum, a square of a sum, a square of a difference, or a sum and difference? And this is a sum and difference. I don't know where I wrote S squared, because there's no linear term. Okay, perfect. How about this one? Is t squared a perfect square? You betcha. How about 81? Is that a perfect square? Yeah, that's 9 times 9. So this one again is a sum and difference because we don't have that central term here. How about this one? Oh, things are kind of weird in this one. It's kind of backwards. Doesn't matter. Backwards, forwards. 16 is a perfect square. That's a 4. X is a perfect square. X squared is a perfect square. The square root is x. And it's a sum and difference because there's no central term there. Remember, the first term and the last term, they have to be perfect squares or this won't work. They got to be perfect squares. Let's take another one that looks kind of freaky. Hey, let's do number 6. Why not? Square, that's a perfect square. That's 9 times 9. This is a perfect square. That's 7k times 7k. So we can factor this now. This is a difference of squares. So we'll do the sum and difference formula. Square root of 81 is 9. We'll put those in the first position. Square root of 49k squared is 7k. We'll put that in the second position. And it's a sum and difference. Okay? All right, let's move on a little bit further. Let's move my mouse over here. Okay, use special patterns to evaluate the expression. Oh, okay, well, yeah, let's just try this out here. 57 squared minus 53 squared, that's a difference of squares. So that's 57 plus 53, and then 57 minus 53. Oh, okay. Well, 57 plus 53, maybe you're not that fast adding it, but 57 plus 53, that's 110. And then 57 minus 53, that's 4. And that's easy to multiply, that's 440. Okay. That's how we were going to play this game. We're going to factor it like it was algebra, but these are just numbers. See, 38 and 32, those are both perfect squares, so we're going to do 38 plus 32 and 38 minus 32. Let's see, 38 plus 32, that is 70. 38 minus 32, that is 6. 70 times 6, 420? Yeah. And yeah, well, I don't think we need to do a whole lot more of those. You know, we're kind of done with that. Let's try these ones. Okay, let's see. Do we have perfect squares? Is x squared a perfect square? Yeah, that's x times x. Is 64 a perfect square? Yeah, that's 8 times 8. Okay, and then this is a plus sign. We have 3 terms, so this is a sum, square of a sum. So x plus 8 squared. Not a whole lot to it, really. Did you want to see what this looks like if you did the x pattern like we did? 196, and then a 28 over here. Two numbers that multiply to make 96 and add to make 28. Well, that's 14 times 14. So that would be p plus 14 and then a p plus 14 also. Like I said, not exactly a whole lot. I mean, yeah, it's a different process, but the amount of time it took to do these two, not particularly much different. Maybe we'll do that again with numbers 15 and 16 over here. That's a perfect square. That's r squared. This is a perfect square. You may or may not see that, but when you do a lot of math, you see that's 13 squared. Okay, this is a minus sign, so we're going to drop that in the middle. So this is going to be r minus 13 squared. Not a whole lot to it. What comes next here? Yeah, I said I would do this one with the x method, so I'll do this one with the x method. This is a little easier. It's definitely not a 196. 81, negative 18. Let's see, two numbers that multiply to make 81 and add to make 18. That's 1 times 81. Nope. 2 doesn't work. 3 times 27. 27 minus 3 is 24, so that's not going to work either. 4, no. 5, no. 6, no. 7, no. 8, no. Oh, 9 times 9. Let's see, if I add 9 plus 9, I get an 18, so that's going to be it, really. That's going to be a minus 9 here and a minus 9 here. And then when we factor that, that's going to be an a minus 9 and another a minus 9. How do you do? That's a minus 9 whole guy squared. Okay? That's lovely. Let's move on. Over here, we're supposed to solve these, the equation. So remember what you're doing. You're factoring, and then you're setting each factor equal to 0. This is a good reminder for you about how we do these. Okay, so perfect square, that's obviously still x squared. That's 12 squared. So we can say x plus 12 and x minus 12. I know it's the sum and difference because there's no linear term. And then from here, we say x plus 12 equals 0. That gives us x equals negative 12. I got x minus 12 equals 0. That gives me x equals positive 12. So my answer is x equals negative 12 or positive 12. Not a lot to it. Take a look at number 20. I think this is a fun one to look at. And I feel like I'm going really fast. Am I going really fast? No. Well, you can slow it down if you need to. All right, so 9y squared equals 49. I'm going to solve that. Let's subtract 49 from both sides. Okay, now that I've done that, I've got 9y squared minus 49 is equal to 0. Are these perfect squares? Let's see, that's 3y squared, and that's 7 squared. So yeah, that's the difference of perfect squares. So that gives me 3y plus 7 and a 3y minus 7. We've used a lot of room, so we're going to go over here, which means that we're going to get a break. We don't have to do 21. Lucky us. Okay, we're going to set each of those factors equal to 0. So 3y plus 7 equals 0. 3y minus 7 equals 0. Don't try to solve both of them at the same time. Do the one on the, I don't know, is that the left, and then the one on the right. So we're going to solve this one first. We're going to subtract 7 from both sides. So 3y equals negative 7, and then we're going to divide by 3. So y equals negative 7 over 3. And we're going to do the same thing here, except for instead of subtracting 7, we're going to add 7. that gives me 3y equals 7. Divide by 3. And then y equals 7 over 3. All right, and let's just box that up. All right, so we've solved 2 equations now. I feel like we should maybe do one more. Yeah, let's do one more. I know you guys don't like the fractions, so of course we're going to do the fractions. All right, let's solve firstly. We've got n squared plus 2/3 n plus 1/9 equals negative 1/9 plus 1/9. So what does that give me? That gives me n squared plus 2/3 n plus 1/9 equals 0. Okay, and that's what you want. You want 0 on the right side so that when you factor, you can use that zero product theorem, which is so important. It's maybe the most important theorem from second semester Algebra 1. Okay, is this a perfect square? Sure, that's n squared. Is this a perfect square? Well, 1 is a perfect square, the numerator. 9 is a perfect square, the denominator. So yeah, this is a perfect square. That's just 1/3 squared. All right, and we play by the same rules. This is n plus 1/3. I get the plus sign from there. The whole thing squared equals 0. And then the nice thing is that if it's a perfect square, you only have to solve this one time. N plus 1/3 is equal to 0. N plus 1/3 minus 1/3 equals 0 minus 1/3. And so n equals negative 1/3. Okay, there is only one factor here. It's a double root, so you're done. That's it. Okay, let's read through this word problem down over here at the very bottom of page 238. The dimensions of a regular prism are x plus 1 by x plus 2 by 4, and the volume is 24 minus 1 cubic feet. What is the value of x? Geez, what the heck is a prism? Prism is well, you can think of it as the shape of a brick, really. A rectangular prism is the shape of a brick, and I mean the kind of brick that you would find on the side of a building. All right, so let's figure things out here. We've got x plus 1. Let's make this x plus 1 over here across the bottom. Let's make this up here. Let's make that x plus 2, even though it should be longer than x plus 1. Uh-oh, my computer's being finicky. And then this over here, we're going to make that 4. And so the volume of any prism is just the product of all 3 sides of the prism. I should say rectangular prism because this is a rectangular prism. So let's multiply all 3 of those together. X plus 2, x plus 1, and 4. Okay, FOIL. X times x is x squared. X times 1 is 1x. 2 times x is 2x. And 2 times 1 is 2. And then we're going to take that and we're going to multiply everything by 4. Let's multiply by 4. You got 4x squared plus, well, that's x plus 2x. That's 3x. Let me make that a little bit clearer. Sorry, I'm getting ahead of myself because I just like it so much. Let's move this down here. And these two together, they make a 3x. Okay, so now we have 4 times 3x, that's 12x. 4 times 2 is 8. Okay, so that's my volume formula. Okay. Well, they also tell me that the volume is equal to 24x minus 1. So this is often what you're going to see in word problems. They're going to give you 2 ways of finding the same quantity, and then all you need to do are take those 2 things and make them equal to each other, because volume is volume is volume. So Sorry, that's me knocking around the batteries inside my pen. That's 4x squared plus 12x plus 8. That's equal to the other part of the volume, which is 24x minus 1. And I'm going to write this over here. Volume is also equal to 24x minus 1. So if those two things are both equal to volume, then they've got to be equal to each other. All right, we're going to do some solving here. You got 4x squared plus 12x plus 8. Let's subtract the 24x, and let's add a 1, and that's going to be equal to 24x minus 1 minus 24x plus 1. Maybe I'm guilty of rushing this a little bit, but I want to get 0 on that right side, so I'm just going to subtract everything out of it. Okay, 4x squared. We've got 12x minus 24x, that's minus 12x. We've got 8 plus 1, that's a 9, and that's equal to 0. And whoa, look at what we got here. This is a perfect square. That is 2x squared. This is a perfect square. That is 3 squared. So when you factor that, you're going to get a 2x, you're going to get a 3, and this is a minus here. So that's going to be 2x minus 3 squared equals 0. All right, now you're going to just have to solve this. This is a perfect square, so there's only one factor, and you only have to solve one time. So 2x minus 3 equals 0. 2x minus 3 plus x plus 3 equals 0 plus 3, which means 2x equals 3, which means x equals 3 over 2, which, if you got your calculator, that's 1.5. Okay, guys, that's the end of this one. Chapter, what did we say? Chapter 7, section 7. Now it's time for you to go forth and do your big ideas. Okay, thanks for coming in, and have a good one.